we could actually feed 9 billion people from a smaller acreage than we feed 6.9 billion today. So can we treble yields? Well, we've just done it. In the last 60 years, we trebled yields. This is the yields of rice, wheat, and maize, the big three cereal crops which provide about 60% of human calories. And they trebled over that time despite taking effectively no extra acres under the plough. Nobody thought this could be done. We were told repeatedly throughout this period by environmentalists such as Lester Brown that it could not be done. And yet it was done. And how was it done? It was done by getting dwarfing genes into wheat so that they put more of their energy into seeds rather than stalks. It was done by the use of machinery and chemicals and fertilizers and all these things that raised yields in farming. And what that did was it enabled us to, well, and what first thing it did was it lowered food prices. And food prices have been on a long-term decline. Now, we've just heard that they're high at the moment. And some people even talk about record highs. But if you correct for inflation, these are not record highs. I mean, this is roughly where we're at the moment. That's actually the 2008 spike, but the 2010 spike is at about the same level as that. It's an uptick and it's causing real pain, but it's from a very low level. And what this means is that by increasing yields, we've actually been able to spare land. If you go in the woods of New England, you find stone fences like this running through the landscape where people used to have farms. New England used to be 70% farmland, now it's 70% woodland. The more we can increase farm yields, the more land we can spare for national parks and wildernesses. There's an interesting calculation done by a guy called Helmut Habel in Vienna, who with splendid Teutonic precision has worked out that human beings are eating 23.8% of all the plant matter grown on the earth each year. That is to say, of net primary production. And he's done the map for different parts of the world, and on the bottom graph you can see this, and the darker the area, the more of the primary production of the earth we're pinching for ourselves and our animals. But the top graph shows something interesting. It's what effect we're having on primary production. Are we raising or lowering the productivity of plants? And it turns out that in some areas like Northern Europe, you can't see it very well on the chart, we're actually raising the productivity of the land, of plants, so much that even though we're pinching a big chunk of it, there's about as much left over for nature as if we weren't here at all. And he says that it's quite feasible to imagine a world in which we take more than a quarter of the plant production for our own use, but that we so increase the productivity of ecosystems through fertilizers and irrigation and things like that, that actually there's just as much left over for wildlife as before. But this, of course, depends on fuel. It depends upon tractors and gasoline and diesel and gas and all these things that agriculture depends upon. Aren't they going to run out? Well, they haven't yet, and we've been saying they will for 150 years, actually. There are predictions going right back to the 1860s of a peak coal, which was predicted by the economist Jevons in 1860s, leading to a British Royal Commission on what to do when the coal ran out. That was in 1860. And people like Jimmy Carter were saying that oil was going to run out imminently in the 1970s. And likewise, the book Limits to Growth in 1970 projected that we were headed for a disaster because of lots of other minerals, lots of other elements and metals and so on running out. It didn't happen. Minerals, on the whole, got more abundant as we got more ingenious at finding them, and they got cheaper. This is the reduction in the price of metals over the last few decades and centuries, and it's been a pretty spectacular reduction in the affordability of all of these metals. And by the way, we've just had a revolution in energy that is really quite extraordinary. It's happened in 2 years, and it's all about shale gas. Until 2 years ago, we thought there was perhaps 30, 40, maybe 50 years of gas left in the world, and that it would perhaps be the first of the fossil fuels to run out. That's now been turned on its head by the discovery of enormous reserves of shale gas which can be economically exploited at prices way down below even the price of getting coal out. Here's a shale gas drilling rig in Pennsylvania producing shale gas, And this is an idea of just how much the estimates of the amount of stuff have changed in the world. The International Energy Agency estimates that there's 250 years' worth of gas in the world now. That's a quarter of a millennium. That surely is long enough for us to find an alternative to fossil fuels if we need to. So the idea that agriculture can't deliver because it's going to run out of gas to make fertilizer just no longer adds up. And by the way, we do indeed need to get energy from somewhere for civilization, and there are lots of ways of doing it. This is one, to put gigantic windmills all over the landscape. And windmills do produce electricity, but it's worth just putting it in perspective. That's how much a wind turbine produces per year. That's how much a single shale gas well produces in a year. And so which would you rather have? 48 of these for 25 years, which is their natural lifetime, or one of those for 30 days, which is how long it's there. When it goes, there's just a Christmas tree apparatus on the ground pumping the gas. That's why I think it's not at all obvious that renewables are greener than fossil fuels. Because renewables have other disadvantages too. Here's a white-tailed eagle killed by a wind turbine in Norway. 24 golden eagles a year are killed by one wind farm in California. Ah, yes, but aren't fossil fuels going to bring a civilization to a horrible halt by warming up the climate? Well, we don't know yet, absolutely, and I'm the first to admit that I don't know. But I'm yet to be persuaded that there is something here that we should be really immediately worried about or alarmed about. It's possible, but it doesn't look to me yet very convincing. We've seen a warming over the last 30 years. This is the satellite data, which is roughly consistent with the ground data. It shows a slightly less of a warming. But this is a warming at a very low rate. It's a rate of less than 0.1 of a degree per decade. It's less than 0.2 of a degree per decade. It's not nearly enough to get us to 2 degrees per century, which is the sort of thing that the International Intergovernmental Panel on Climate Change talks about. And we're seeing other signs that the world is getting warmer, or sea level is definitely rising, although it's not showing any sign of acceleration, and it's been rising since long before human impact started. Greenland, it's rising, by the way, the sea level at about the rate of a foot a century. And I think on the whole, human civilization can probably work out how to cope with a foot a century. Greenland is indeed losing ice. It's losing ice at the rate of about 200 cubic kilometers a year. That's a large number. Put it in perspective, though, it's less than 0.5% per century. So Greenland will be 99.95% intact after 100 years. That doesn't yet seem to me to be something we need to worry about. Glaciers are retreating, yes, but they have been since the middle of the 19th century, since we started coming out of the Little Ice Age. There's no particular evidence of an acceleration in recent years due to human impact. The frequency of storms is roughly the same as it's always been. In fact, it hit a record low in the last year or so. And we've now had the global warming scare for long enough to start to look back at some of the predictions that were made about it at the start. And here's one that Jim Hansen produced in 1986, in which he drew a number of lines depending on what we did about carbon emissions. And the top line that you see is the one that will happen, he said, if we don't do anything about carbon emissions. In fact, our carbon emissions have gone up faster than in that assumption. And yet, this is where the temperature has ended up, way below all of the lines. So when people say that global warming is happening worse than predicted, I simply don't know what they're talking about. It seems to me to be happening less badly than predicted. Now, there's plenty of evidence that it may accelerate, etc., etc. We should be concerned about it, but I'm not yet convinced that it's going to derail civilization. In fact, there's plenty of evidence. For example, the tree line in the Urals is lower than it was in the Middle Ages. We're not yet in uncharted territory in terms of warmth, even in this millennium, let alone in this interglacial period, when we had a much warmer period. That's the interglacial. We're just coming out of the coldest part of it, the Little Ice Age, back in the medieval, the Holocene optimum 7,000 years ago. It was a good deal warmer. That's when the Sahara was green and so on. And This is, to me, one of the most disturbing things about the whole climate debate, because this is from a lecture given by Richard Muller at Berkeley just recently, and it shows the effect of that notorious email about using Mike's nature trick to hide the decline. This is what was meant by this. This is what the tree ring data shows, a downward dip at the end. And watch what happens when you use Mike's nature trick to hide the decline. So I think we're almost exactly on course for a mild warming in this century that is completely consistent with a full greenhouse effect from carbon dioxide, but is not consistent with the kinds of positive feedbacks that are built into most of the models and that predict a 3 or 4 degree warming. But even if it does happen, are we really sure that that we're not going to be able to cope with it as a civilization? After all, we've had warming in the 20th century, and something like malaria actually retreated dramatically during this century. The graphs show where malaria was in 1900 and where it is today, and the blue chart at the bottom, the blue on the chart at the bottom shows where malaria has retreated. The red on the chart at the bottom shows where malaria is getting worse. Now, malaria didn't retreat because we did something about the climate. Malaria retreated because we did something about human behavior, human living standards, human technology, human infrastructure. We basically went indoors at night and closed the windows and things like that, and we defeated mosquitoes in all sorts of different ways. The number of deaths from extreme weather, that is to say floods, droughts, and storms, is 93% lower than it was in the 1920s. The probability of dying in extreme weather is 98% down from what it was in the 1920s. This isn't because storms have got less dangerous. It's because we're better at defending against storms and droughts and floods. We're better at making sure food gets to people in droughts. We're better at communicating and transporting people, and we're better at defending ourselves generally. And I think that's likely to continue, even with quite severe warming in the next decade. And it's worth remembering that the more carbon dioxide we put in the atmosphere, the faster our crops are going to grow. The rate at which crops grow depends on the ambient concentration of carbon dioxide. And that's what a plant looks like grown in 750 parts per million of carbon dioxide. And that means that plants have less demand for water and things like that, so actually they'll be able to survive droughts better. Besides, we are actually progressively decarbonizing our economy. We're not doing it fast enough, perhaps, but we are doing it. We've been doing it for 150 years, not because of policy, but because of technology. As we shifted from wood to coal to oil to gas, we shifted from a high carbon, low hydrogen fuel to a high hydrogen, low carbon fuel. And we're on track to have about 90% hydrogen and 10% carbon in our fuel mix sometime around the late 21st century. Well, I've given you some reasons why I, on the whole, think that this century is going to be great and that most of the worries we have about it are overblown. I'm certainly not saying that bad things won't happen. There will be wars. I don't think we'll extinguish wars. There will be natural disasters. There will be man-made disasters. There will be dictators. There will be idiotic things done by human beings. We always will do things like that. But isn't it necessary to be pessimistic? Isn't it a better idea to be cautious and worried because then we can solve our problems? Well, actually, I don't think so. Archimedes, when he set out to solve problems, he was living in the richest part of the world at the time, in ancient Greece. And he was in the most ambitious civilization on the planet, not the most worried civilization on the planet. You can say the same of Al-Khwarizmi in Arabia, and Fibonacci in Renaissance Italy, and George Stephenson in Victorian Britain, and Thomas Edison in 19th century America, and Steve Jobs today. Each of them lives in the richest place in the world at the time, and in the place with the most ambition, and the place with the most optimism, and the place with the most hope. You don't get innovation out of despair. There isn't a lot of software innovation going on in Zimbabwe at the moment. Well, isn't it complacent to be an optimist? Isn't that a sin? Well, I don't think so. I actually think that what is complacent is to think that today's technologies are good enough and that we can't do better. And to think that that we should prevent genetically modified food because